Thank you for watching this project help video for lesson 16. I will help you answer each question in the project by providing step-by-step example problems. A good strategy might be to pause the video after each example and then work the corresponding project problem in your project. All right, let's begin with question 1. The function f of x equals 25x plus 6 represents the number of shots LeBron takes during a given season. X represents the number of games since the start of the season. What is the domain of the function? All right, so when we talk about functions, we often talk about two different characteristics, one called the domain of the function and another called the range of the function. The domain of a function is all the possible input values. So sometimes it makes sense that the possible input values are all real numbers. I can plug any number in. Other times it doesn't make sense to have all inputs, or it is not possible to have all inputs into a function. For example, we can't divide by 0, and we can't take the square root of negative numbers. Other times, the restriction may come from the context of the problem. So let's go ahead and read what this function is representing here and what the input or what the domain is representing. Remember, the domain is all the possible x values. And here it's telling us that x represents the number of games since the start of the season. So when I'm trying to decide what the domain is, what are the possible inputs for that number, ask yourself three questions. Can it be a negative number? Can it be 0? Do positive numbers make sense? And then lastly, what about fractions or decimals? Would they make sense? All right, so since x here is representing the number of games since the start of the season, it doesn't make sense that it would be all real numbers, right? Because the number of games since the start of the season cannot be negative. Remember, all real numbers would include negative numbers, decimals, any number you can think of is a real number. So the domain is clearly not all real numbers. All right, next here, how about this? Any real number where x is less than 0. Well, we just got done saying that the number of games has to be positive, right? You play 1 game, 2 games, 3 games, 4 games, right? All positive number of games. And that set is in fact defined by the natural numbers. So the natural numbers are those counting numbers, the ones that start at 1, then go to 2, then 3, and they're whole numbers. Notice that in this case, the domain can't be a fraction, right? We can't have 2.5 games. You either have a game or you don't have a game. All right, so how many shots will LeBron James have taken after 10 games? So remember here, X is representing the number of games. So I like to call this type of problem plug and chug, right? It is telling us that X is equal to 10. So you might have seen this type of problem before in previous classes where they give you some kind of expression and then they say let x be some number and you just have to plug it in and solve using the order of operations. Don't let the function notation throw you off, right? This over here does not mean f times x. It is not a different variable, right? It's a new way that we define a function. It's just a different notation than what you're used to. You can think of this as being the y. You're used to seeing a y there. Now we're going to use f of x. So x is the inside the parentheses here is indicating what the input variable is. Right? So it's pretty convenient for mathematicians to use this notation. And this is one way we would use it. We could write f of 10 is equal to 25 times 10 plus 6. There is no work to do over here on the left-hand side. This is like saying the answer when I plug in a 10 is, and then here's all the work on the right-hand side of the equation. Right, so this is like we're just naming it. This is how we're naming it over here. So we're saying when we plug in a 10 into this function, that's another way to say let x be 10. This is how we do it now. We're using function notation, much more clean and concise. Now we do all the work over here. Okay, so following order of operations, I would get 250 plus 6. All right, so f of 10 is equal to 256. Remember, the answer here would be 256. If you were asked how many shots will LeBron James have taken after 10 games, well, 256. That doesn't mean he made 256, remember, it just means he's taken that many shots. All right, so the function g of x equals 31x plus 15 now represents the number of shots Steph Curry attempts in a given season. Again, x is representing the number of games since the start of the season. We're going to write the function that represents the total number of shots attempted by LeBron and Steph in a given season. All right, so now we're talking about performing function operations. And one of the things we can do with functions is add them, subtract them, multiply, divide them, just like you can do with real numbers. We can do that with functions also. So here it's literally saying like LeBron plus Steph. So I'm going to take each of their individual functions here and we're going to add them together. Remember this out here, the function notation, that's like saying y, right? That's just what we're calling the function. We're just naming it. F of x, g of x. And now we want to add them together because we want to know the total number of shots attempted by both of them. All right, so when I add the two functions, I'm going to come up with another function. So maybe I call it something else. Maybe I call it k of x. It doesn't matter. Remember, we're just naming it. And I need to add the two functions together. So I need to add what I'm underlining here to this one. So it'd be like writing 25x plus 6 added to Steph Curry's function, 31x plus 15. And then now, just like you've always done when you have like terms, you can combine them. So here's our x terms, 25x and 31x. So I'll write k of x here is equal to 25 and 31. That's 56x. And now we can add the constant, the whole numbers together here. 6 plus 15 is 21. All right, so this is the function here that would represent the total number of shots attempted by LeBron and Steph Curry in a season, right, given these individual functions. That's just function addition. We're just adding them. All right, so question 4. The chart below shows the starting lineup for the Cleveland Cavaliers and each player's average points per game, excuse me. Which elements are in the domain for this relation? So this is actually an easier question than you might think. Super easy. All right, so the domain, like I said in slide 1, is just the set of all the x values, the inputs. It's the set of all possible inputs. So here we're given a table. And the inputs, or the x variables, are the ones in this first column here. These are our x values, or the domain. These are our y values, or the range. So this is literally just saying what elements are in the domain. It's like saying what are the x values. So we could write it out. All right, and typically you would write this using set notation. So this curly Q bracket means the set of, and then I can write the numbers. Now, just to be nice, you could write them in order from lowest to highest, but it's not necessary. But I will just to make it a little nicer to read. We have a 0, we have a 2, we have a 20, a 23, and a 24. So in your project problem, it says select all the ones that are in the domain. You're just clicking all the ones that are the x values, the ones in the first column. Easy, easy. Same thing with question 5. Same table, different numbers, same idea. So if this chart represents the lineup for the Golden State Warriors and their average points per game, what elements are in the domain of this relation? Well, here they are. They're the x values again. That's all you're looking for. So I'm going to go ahead and write out the set. All right, so I'll do it in order from low to high, but again, that's not necessary, but I'll do it just uh, so it's a little easier to read. 11, then we're going to get 23, then notice there's another 23, and we don't list the same element twice. All right, there's 23 is in the domain. It's in there twice in this case, but we don't list it twice. All right, then we have 30, then we have 35. All right, so those are the elements in the domain for this relation. Again, easy, easy. All right, so now this last question is saying, although both of the charts that we were just looking at, for the Cavs and the Warriors, they're both relations, but only one of them is a function. Which relation is a function and why? All right, so let's back up and talk about what a relation is. So a relation is any X or and Y pairing, any pairing of a domain in a range. Any X with any Y, anything goes. All right, but a function is a special type of relation. All right, so a function is a relation where each element in the domain is paired with exactly one element in the range. So each X has one and exactly one Y paired with it. It's another way to think about it. So let's take a look back at the Cleveland Cavs chart here. So in this case, we have 5 different elements in the domain here, and they're all paired with exactly one element in the range. So this, in fact, is a function. So when you're looking at ordered pairs, or an X and a Y like we are here, or a table, the real quick and easy way to guarantee that something is a function is just to make sure that all the X values are different. Here, let me repeat that because you really need to pay attention to it. When you're looking at a function, if you're looking at either a set of ordered pairs or a table like this, all you have to do is look at the X values and make sure they're all different. If they're all different, then it's going to be a function because each X will be paired with exactly, in this case, one Y. Now it's okay if we have repeats going on out here in the Y, just not in the X. So now take a look at the Golden State Warrior table here. Notice where we have 23 repeated here. So this is saying 23 scores 13 points a game, and then down here it like contradicts itself and says 23 scores 16 points a game. That's what makes this not a function, because we have a single element in the domain, 23 in this case, paired with 2 different outputs. Right? If it was a function, it would be paired with exactly one output. And think about it in this case, I kind of like to think about it as these are players, right? These are their jersey numbers. So we have whatever player has jersey number 23. And in fact, I believe that's Damon Green on the Warriors, right? In this case, the table's telling me that he scores 13 points a game. But down here, it's like contradicting it, saying jersey number 23, Damon Green scores 16 points a game. Well, he does one or the other, right? He doesn't do both. And that's what makes this another reason why this is not a function. A function wouldn't do that. It takes one input and gives exactly one output. All right, so go ahead and make sure you answer the corresponding problems in your project. And if you have questions, you can call, message, or email me. Thank you.